The last question of this paper is question 7 from work, power and energy. Work, power and energy. The diagram shows the vertical cross section x, y, z of a rough slide. X, Y, Z is a rough slide. The section YZ is a straight line of length 2 meter inclined at an angle alpha to the horizontal. YZ is a straight line. XY is a curved part of the slide where sine alpha is given, that is 0.28. The section YZ is tangential to the curved section XY. This is it looks like a tangent at this point. YZ is tangential to the curved section XY at Y, and X is 1.8 meter above the level of Y. Above the level of Y, X is 1.8 meter above the level of Y. A child of mass 25 kg slides down the slide starting from rest at X. A child of mass 25 kg slides down from here starting from rest at X. Rest means here the speed will be 0. Speed is 0 at point X. The work done by the child against the resistance force in moving from X to Y is 50 joule. From X to Y, the work done by the child against the resistance is given, that is 50 joule from X to Y, and that is the curved part of this slide. Find the speed of the child at Y. We have to find the speed of the child at this point Y. So we will use here a work energy equation or simply work energy relation. So this is very important formula for work, power and energy. Work energy relation is work energy relation or this is simply, you can say that this is a very important formula for work energy relation. WD, I am using here short form. WD mean work done by driving force. WD mean work done by driving force is equal to work against friction. WF mean work against friction plus change delta. Delta shows change in mechanical energy. Now in this formula, when we will apply this formula, we will not take the weight component. We will not take the weight components. So because weight component is merged in this formula, this is called work energy relation. Work done by driving force is equal to work against friction plus change in mechanical energy. Delta shows the change in mechanical energy. Now, first of all, I will explain, I will define what is mechanical energy. Mechanical energy is equal to potential energy plus kinetic energy. This will be equal to mechanical energy. Change in mechanical energy means final mechanical energy minus initial. Final mechanical energy minus initial mechanical energy, that is called the change in mechanical energy. So we are using this formula. So in this formula, in this question, WD is work done by driving force is zero because no driving force here. When the child starts its motion, no driving force. Start from rest. So work done by driving force is equal to zero here. So we write here work done by driving force is zero. Work done against friction, that is given 50 joule. We write here 50. But now we have to find mechanical energy, change in mechanical energy. And let this is equation number one for reference. Now we will find mechanic change in mechanical energy. So we will find mechanical energy at point X and Y. Then we will subtract mechanical energy at Y minus mechanical energy at X. We get the change in mechanical energy. So first we find mechanical energy at point X will be mechanical. ME shows the mechanical energy at point X will be potential energy plus kinetic energy. Potential energy is mgh. mgh kinetic energy 1 over 2 mv square. Now mass of the child is given, that is 25 kg, and this height is from X to Y. Height is given, that is 1.8 meters. So putting here values, kinetic energy in this at point X will be 0 because speed at X u is equal to 0 because start from rest. So uh, mgh, m is 25, g is 10, uh, h is 1.8, so we get this is equal to 450 joule. Mechanical energy at X is 450 joule. Mechanical energy here is 450 joule. Similarly, we will find the mechanical energy at this point Y. In the same way, mechanical energy at Y will be mgh plus 1 over 2 mv square. Mgh plus 1 over 2 mv square. Now mgh, now for this part of the slide, this part will this point we are taking this point y as a level. So here the height will be 0. So there, this means that there is no potential energy. So potential energy, because height is 0, so uh, we are taking potential energy is 0. So we are right here 0 plus 1 over 2 mv square. M is 25 and v square, v we have to find at point y. We have to find the speed. Find the speed of the child at point y. So now we are putting the values of mechanical energies. Change in mechanical energy means final mechanical energy minus initial mechanical energy. Putting in this uh, equation number one, the values we get from equation one. Work done by driving force is 0 is equal to 50 plus change in mechanical energy, final mechanical energy. Mechanical energy is this. We can write it 12.5 V square. So 12 point change is 12.5 V square minus mechanical energy at X is 450. So minus 450. Calculating, simplifying it, we get 12.5 b square minus 400 is equal to 0. From here, 12.5 b square is equal to 400 and b square is equal to 400 over 12.5. Using a calculator, we get the value of v, that is 5.66 meters per second. This is the speed of the child at point y. The next part of this question is, it is given that the child comes to rest at z. Now this part of the slide is straight because it is tangential at y, yz is straight. So angle is given and this yz is also given, that is 2 meter, and sine, the value of sine alpha is given 0.28. We are making here the diagram again. Now first we have to find the values of sine alpha and cos alpha. Sine alpha is given. We also need a value of cos alpha in this question. So from this we can find the value of cos alpha by uh, making a right angle triangle. Since sine alpha is given, that is 0.28. 0.28, this means that sine alpha is equal to 28 over 100. Now we make a diagram at a right angle triangle. This angle is alpha, and sine alpha 28 over 100 mean perpendicular over hypotenuse. So we will write here perpendicular is 28 and hypotenuse 100. By using the Pythagoras theorem, we get third side, that is 96. So from here we can say that cos value of cos alpha will be base into height, 96 over 100. That is 0.96. Now it is given that the child comes to rest at z. At point z, the speed will be 0. We are making again the diagram for this part. Use an energy method to find the coefficient of friction between the child and yz. Because the surface is rough, we have to find the coefficient of friction. Because the surface is rough, we have to find the coefficient of friction between yz and the child. Giving your answer as a fraction in its simplest form. For this part of the question, diagram will be like this. This is a slope. This angle is making an angle alpha with the horizontal. This angle is given, that is alpha. This is yz. This point is y. This point is y and this point is z. And the child is at point y. That this is child. The weight of the child will be acting vertically downward. Mg, we resolve it and find two components, one along the plane and the other is perpendicular to the plane. These are the components of this weight. This angle is alpha because this angle alpha, this is also alpha. Now reaction of this plane on this child is normal reaction is R. Now we will solve this part of the question by energy method again. Energy methods again, we are writing here the energy method. This point is Y and this point is Z. Now again we are using this formula WD, work done by driving force, is equal to work against friction plus change in mechanical energy. So let this is equation number 1 for reference. Now first of all we will find the work done by against the friction. Work against the friction, that will be work against friction will be, this is formula for work, F into D. F is the force of friction, that is mu R. Mu is involved here. And D is given, that is 2 meter, Y Z is 2 meter. So this D is 2. Just we have to find value of R. R will be equal to this force component of the weight that is acting perpendicular to the plane. This is mg cos theta. This component is mg sin theta. Not theta, but in the question there is alpha, so we are using alpha here. Mg cos alpha, and this component is mg sin alpha. Now the value of R will be equal to this force because direction of both forces are in opposite direction. So R will be equal to mg cos alpha. Here we will use this value R mg cos alpha. So this becomes Wf will become mu into mg cos alpha into d. D is given, that is 2. Putting the values, mu mg cos alpha means 25 into 10 into value of cos alpha. We have already found cos alpha is 0.96, so we are writing here 0.96 multiplied by 2. So after simplifying this, we get work done by against the friction is will be equal to 480 mu. Now this is just we have found WF, work done against friction is 480. Now we will find a change in mechanical energy. So for this we will find mechanical energy at Y and mechanical energy at Z. Then we will subtract the mechanical energy at Z and mechanical energy at Y. We will find change in mechanical energy. So for this we are finding mechanical energy at Y. Mechanical energy at point Y is equal to mgh plus 1 over 2 mv square. Putting the values, m is 25, g 10, and h, here we have to find h. H is this height of point Y and Z is this. This is the height. This is height. We have to find this height. We will use the ratio perpendicular over hypotenuse. This is h over 2 is equal to sine alpha. This is height of point y and z, and it is h. So we are finding here the value of h from the diagram. H perpendicular over hypotenuse is equal to sine alpha. Sine alpha is given, that is 0.28. So we can write here h over 2 is equal to 0.28. From here h is equal to 0.56 meters. So we have found that this height is 0.56 meters. So we are putting here the value of height 0.56 plus 1 over 2 mb square mgh 25 into 10 into height is 0.56 plus 1 over 2 m is 25 v square. V square just we have found in the above part, that is speed at y is 5.66. We are taking this value here 5.66 square. Now simplifying it, we get uh, 140 plus 400. We get this 540. 540 mechanical energy at y is 540 joule. We are taking this as a rounded figure because we have to give the answer in answer as a fraction in its simplest form. So this is a rounded figure 540. Now similarly we will find the mechanical energy at point Z. At Z, mgh plus 1 over 2, mgh is potential energy, plus 1 over 2 mv square, that is kinetic energy. Mgh is 0 and 1 over 2 mv square, that is also 0 because speed is 0 at z. It is given that speed is 0 at z and height is decreasing, and at the level height is also 0. So both energies are 0. So we get 0 plus 0 is equal to 0. Now mechanical energy at Z, we have 0. Mechanical energy at Y, we have 540, and work done against friction is 480 mu. We are putting these values in equation number 1. So from equation number 1, work done by driving force is equal to work against friction plus change in mechanical energy. Putting the values, we get work done by driving force is 0. Work against friction, just we have found 480 mu plus change in mechanical energy. Final mechanical energy at Z minus mechanical energy at Y. So we get this 0 minus 540. So simplifying it, we can find the value of mu in a fraction. So 480 mu minus 540 is equal to 0. 480 mu is equal to 540, and from here mu is equal to 540 over 480. After simplifying, we get the value of mu is 9 over 8. This is the answer. This comes to an end.